Okay, so this is pure for January 2022, I think. Well, that's what it is now anyway. Okay, let's go through this. So, if you start by pausing and giving the question a go, and then you can watch me go through it. Okay, question number 1, 6 marks. Are we ready? So, the curve C has equation xy squared equals x squared y plus 6. Find an equation for the tangent to C at the point 2, 3, given your answer in the form ax plus by plus c equals 0. Okay, so first of all, if we want an equation for the tangent, we know we need to find an equation in the form y equals mx plus c. Okay? To find an equation in this form, we need a coordinate, which we have, and we need a gradient. Currently, we don't have the gradient, so we need to differentiate this. And we know that this is implicit differentiation. Okay? So we have a few product rules happening. So, first of all, x multiplied by y squared equals x squared multiplied by y plus 6. We need to differentiate all of this. So we know we're going to have v and u, v and u. So we're going to have v du plus u dv. Okay, so my v is x multiplied by my differential of u. Y squared differentiated is 2y. And then what do we write when we differentiate y? 2y. Yeah, dy by dx, absolutely. And then this equals, plus u, which is y squared, dv. The differential of v is just 1. Brilliant. So then this equals, is this a 6? Yeah. Don't know why I put c. Okay, so v, x squared, differential of y is dy by dx, plus u is y, differential of x is 2x, so 2xy. And then 6 differentiates to nothing. Okay, so we need to put the dy by dx's on one side. So 2xy dy by dx minus x squared dy by dx equals 2xy minus y squared. Factorise. So dy by dx brackets 2xy minus x squared equals 2xy minus y squared. And we're going to divide both sides, so we're going to have dy by dx equals 2xy minus y squared all over 2xy minus x squared. Perfect. So now to find the gradient, I'm going to substitute in 2 and 3. So I'm going to have 2 lots of 3 minus 3 squared divided by 2 lots of 3 minus 2 squared. Okay, what does that give me? So then the gradient is 3 over 8. So now we have our gradient 3 over 8. So now how do we find the equation of a straight line? We can use y equals mx plus c. So I'm going to have 3 equals 3 over 8 lots of x plus c. So 3 equals 3 quarters plus c. 4, 8, 12. So is this 9 over 4 equals c? Perfect. So now we know that c is 9 over 4. We're going to have y equals 3 over 8x plus 9 over 4. However, it wants it in the form ax plus by plus c. Now, the best way to do this is to multiply by the largest denominator, which is 8. So we're going to have 8y equals 3x plus 18. Okay? Then we need to move everything to the left-hand side. So we're going to have minus 3x plus 8y minus 18 equals 0. You could also have had 3x minus 8y plus 18 equals 0. Either or is correct. Okay, they're both equivalent. And then that is going to give you 6 marks. Nice and easy. Okay, question 2. Find in ascending powers of x the first 3 non-zero terms of the binomial series of this expansion, given each coefficient is simplified fraction. Okay, the first thing I want you to do with this question is I want you to rewrite this in index form. Then what I want you to do is have a look at the formula sheet, and in the formula sheet you can see it says 1 plus x to the power of n. Okay, first of all we have to check, are they both 1? If they are, fantastic. If not, we have to factorise something out, yeah? Next, this 4x cubed is now your x. So everywhere you see an x in the formula, you're going to write 4x cubed. And then finally, your third is your n. Okay, so I'm going to take a picture of the formula and show you how I'm going to substitute this in. Okay, so this is from the formula sheet. So let's have a look. The first term is going to be 1 plus n. Now what is our n? A third. Multiplied by x. What is our x?
4x cubed.
Yes, 4x cubed. Please make sure that we're using the substitution correctly. Plus, and then we have n, which is a third. N minus 1, a third minus 1, over 1 times 2. Lots of x squared. Remember our x is 4x cubed. Okay? And how many terms does it want? 3. Oh, perfect. This is the first 3. This is lovely. Okay? If we were to do 4, we'd do a third minus 1, a third minus 2, over 1 times 2 times 3. But we only need 3 terms. Okay? So make sure you read the question. It just says the first 3 terms. So let's put this into our calculator. So we're going to have 1 plus 64 over 3. Oh, no, sorry. Been very silly then. 4 over 3 x cubed. I accidentally cubed the 4. Okay, then minus 16 over 9 x to the power of 6. Okay, make sure you square this 4 as well. That's how you're going to get the 16 over 9. Given each coefficient as a simplified fraction. Okay, I cannot tell you how easy was that for 4 marks. Really simple. Brilliant. Now it says, use the expansion from part A with x equals a third to find a rational approximation to the cubed root of 31. Now, before we start this question, and before we just substitute in, okay, x equals a third into our expansion, first step we're going to do is, we want the cubed root of 31. If I substitute in 1 plus 4 lots of a third cubed, what do I actually get? That's my first step. We're going to find out what this is going to give me. Okay, so just what I've put into my calculator is just the inside bit, okay? So technically, we're going to have the cubed root. If I substitute in a third, I get 31 over 27. However, what do I want? I want the cubed root of 31, right? So let's think about this. Cubed root of 31 over 27 is the same as the cubed root of 31 multiplied by the cubed root of 1 over 27. What is the cubed root of 1 over 27? So the cubed root of 31 multiplied by, now if I cube root 1 over 27, we should get 1 over 3. Oops. Which we do. So technically, I've got the cubed root of 31 times a third. So when I substitute in a third, I'm actually getting the cubed root of 31 divided by 3. But I want an approximation to the cubed root of 31. So if I've got the cubed root of 31 divided by 3, how am I going to find the approximation to the cubed root of 31? I need to multiply my answer by 3. Okay, so what this means is when I substitute into this, I'm going to have 3 lots of 1 plus 4 over 3 lots of 1 over 3 cubed minus 16 over 9 lots of 1 over 3 to the power of 6. This is what I need to substitute into my calculator. And I want 3 lots of this. Okay, so this gives me 3 lots of 6, 8, 6, 9 over 6, 5, 6, 1. If I multiply this by 3, I'm going to have 6, 8, 6, 9 over 2, 1, 8, 7. Now, if you press SD, okay, SD, I'm going to get 3.14, okay? And if I type into my calculator the cubed root of 31, I get 3.14. So I know I've done a good approximation. I double check.
How did you do this approximation? Okay.
So you can see here, you know you're on the right path because we've managed to get 3.14, and when you type into your calculator the cubed root of 31, you should be getting the same answer, 3.14. So, question number 3, 9-mark question. Pause it, give it a go. Okay, so that we need to show that the Cartesian equation equals this. So first things first, let's rearrange x. So x minus 3 equals 2 sine t. So x over 2 minus 3 over 2 equals sine t. Okay, then next up, what are we going to have? What does cos 2t equal? So using double angle formula, we know this is 1 minus 2 sine squared t. So we know that cos 2t minus 1 divided by minus 2 equals sine squared t. Is that right? Wait, what? If I just completely couldn't... No, we don't even need to go that far. Wait there, guys. So that means cos 2t could actually be 1 minus 2 lots of x over 2 minus 3 over 2 all squared, could it not? Yes. So now we're going to have y equals 6 over 7 plus 1, no, yep, 1 minus 2 lots of x minus 2 minus 3 over 2 all squared. Okay? Are we all here at this stage? Now it's just a case of algebra manipulation to get to 12 over. So let's see what happens here. So we're going to have 6 over 7 plus 1 minus 2 lots of. Okay. I'm going to get x over 2. Actually, if I take out... no. Minus 3 over 2, x over 2 minus 3 over 2. So I'm going to get x squared over 4. Minus 3x over 4 minus 3x over 4 plus 9 over 4. Okay, so I'm going to get 6 over 7 plus 1 minus x squared over 2. And then minus 3x minus 4. Minus 3x minus 4 is minus 6x over 4 times negative 2 is positive 6 over 2, which is 3x. And then we're going to have minus 9 over 2. Okay. Someone just make sure you check my negatives. Okay, so then from here, now I have a denominator of 2. If I can multiply everything by 2 now. If I multiply everything by 2, I have to multiply each term by 2. Okay? To get rid of this fraction. Essentially, what I'm doing is multiplying by 2 over 2. Because I'm multiplying them by 1. So I'm going to get 12. Now, guys, is this 12 a good sign? Yes, because that's what we have in the question. So 12 over... Oh, what is 7 plus 1? 8. What's 8 times 2? 16. Minus x squared, because that's that times 2, plus 6x minus 9. Okay, so I've multiplied every term by 2. This is going to give me 12 over 16 minus 9 is in fact 7. So minus x squared plus 6x minus 7. Okay, which is going to give me 12 lots of, and now I need to factorise this. I'm going to have a positive x and a negative x. Two numbers that multiply to give me minus 7 but add to give me 6. It's got to be 7 and 1. They've already given it us in the equation. However, we can double check that's true. Okay, that is 6 marks. Therefore, shown. Okay, that is 6 marks. I actually haven't finished the question yet. It still wants P and Q. However, that is 6 marks for literally algebra manipulation, isn't it? Apart from the beginning bit with the trig identity. A lot of that was that. Now, it wants us to find the domain of this. What do we know about the domain of the Cartesian equation? It's the range of the x equation in the original thing. So we just need to find the range of the x equation, 3 plus 2 sine t. Now, if you think about sine t, what does the graph look like? Like this. So the range is between 1 and minus 1. But what happens when we do 2 sine of that? We multiply it by 2. Now what happens if I add 3? Yeah, this is going to move up to 5, and this is going to move up to positive 1. So my range is between 1 and 5. So that means 1 is less than or equal to x is less than or equal to 5. Sorry, just realised as well there was a little typo. That should have said plus 7. Okay, and then we have our domain, which is 1 is less than or equal to x is less than or equal to 5. So there we have 6 marks. Nice and easy. Okay, part B. So let's have a look at part B. Okay, it then says, hence find a Cartesian equation for C in the form of this. So what do we want? Partial fraction. So that means that 12 over 7 minus x, 1 plus x, is going to equal a over 7 minus x plus b over 1 plus x. Now, they've done something a bit cheeky in this question, and I'll show you towards the end of it. Yeah. So, what do we know? We know that 12 is going to equal a lots of 1 plus x plus b lots of 7 minus x. So, let x equal negative 1. I get 12 equals 8b. So, b equals 12 over 8. 6 over 4, 3 over 2. Perfect. Okay, and then when x equals positive 7, I get 12 equals 8a. Do they both equal 3 over 2? Oh, wow. Okay. So now, I'm going to have 3 over 2 lots of 7 minus x plus 3 over 2 lots of 1 plus x. Okay, so we need to expand, etc. So we're going to have 3 over 14 minus 2x plus 3 over 2 plus 2x. Now, have a look at the question and have a look at our answer. Does it look okay? Absolutely not. Yeah, you've got that right. This is wrong on so many levels. First of all, we have some 2's. Okay, they just have x. Okay, they don't have a negative x either. So how are we going to get from here to that? So, the main point here, though, is that we need a positive x. Okay, how are we going to get a positive x here? What do I need to multiply this by? Minus 1 over minus 1. Why? Because then we're still multiplying by positive 1. So, we're going to get y equals minus 3 over 2x minus 14. This is the exact same as what we've just written. Okay? This is completely equivalent. We need to have this positive x plus 3 over 2 plus 2x. Now, if you left it like this, you would get full marks. Yeah, you'd get the full 3 marks. Even though they've been a bit naughty in terms of they haven't put a coefficient in front of the x, ideally what they're looking for here in the mark scheme is to have both x's positive. Okay? However, in the mark scheme, it still says OE. So technically, even if you've written this, you would still get 3 marks. because it's still equivalent. We haven't actually changed the quantity. By multiplying by 1, we haven't changed the quantity. So this would still give you 3 marks. So it was actually a really easy question. And I think they just made a bit of fuss and tried to overcomplicate the situation. Question 4. Do you know? Year 13. Would you agree that this is the most beautiful structure you've ever seen?
Yes.
It is, isn't it? Yeah? So, a regular isohedron. Great. Does anyone know how to pronounce this word? Isosendron.
Yeah, the H is
Okay. Of side length 8 centimetres shown in figure 1 is expanding, uniformly. The iso consists of 20 congruent equilateral triangular faces of side length 8. Okay, first of all, what do we know? Okay, so we want to find the surface area. So first of all, we know there are 20 equilateral triangles, and this is going to give me my surface area. Everyone should be able to write this. Now, the side length is x. So this is x, okay? How do we find the area of a triangle? Yeah, so we could do 2 things. First of all, we could do base times height divided by 2. Okay? If I was to do base times height divided by 2, I'm going to have to get some Pythagoras involved, aren't I? Looks a bit messy. We have another way. How else do we find an area of a triangle? A half AB sine C. Do we know what the angle is? Absolutely. It's 60. So instead of using base times height divided by 2, I know I'm going to have to use Pythagoras. It's going to be messy, and I am year 13. I should be intelligent. Okay? So a half times A times B times sine C. Okay, I suggest you make sure your calculator is in radians. Or degrees, actually. No, yeah, sorry. Put in degrees. It will give us the same answer. Okay, what is sine of 60? I think it's a nice number. Root 3 over 2. So I'm going to get a half x squared times root 3 over 2, which is going to give me root 3 x squared over 4. Now, so this is the area of one triangle. How many triangles have I got? 20. We're going to multiply this by 20. And believe it or not, what are we going to get? 5 root 3 lots of x squared. How simple was that? It was, wasn't it? Brilliant. Okay, next says, given that the volume of the iso is this. Brilliant. Show that dV/dA. Wow. So, we've got to differentiate V with respect to A. Okay, so V equals 5 over 12, 3 plus root 5 x cubed. Okay, we're going to differentiate V with respect to A. But what do we notice? If I differentiate V, what do I get? I'm going to get dV dx, aren't I? Okay. What do I want? dV dA. So I know I need a dV multiplied by a dA. Tell me what else is the only other letter that we've seen. X. So this is what tells us our formula. So I need to do dV dx and multiply it by dx dA. However, I don't have dx dA, but I can differentiate A by x and then do 1 over. So let's sort all this out then. So I'm going to have, let's start with dV dx. So first of all, I'm just going to expand. So I'm going to have 15 over 12. I'm so confused. So 15 over 12x cubed plus 5 root 5 over 12x cubed. So then if I bring the power down, differentiate. Multiply by 3. What's 15 times 3? 45 over 12x squared plus 15 root 5 over 12 x squared. Okay, so here's my differential of v. Now I need to differentiate a. So what did we know? A equals 5 root 3x squared. So dA by dx equals 10 root 3x. So now dv dx multiplied by dx dA is going to give me 1 over 10 root 3x. So I'm now going to have dv dx equals, no, dv dA equals 45 over 12x squared plus 15 root 5 over 12x squared all over 10 root 3x. Okay, so now I can cancel out an x from everything, and I'm then going to have 45 over 12 divided by 10 root 3 is root 3 over 8. So root 3 over 8x plus 15 root 5. I'm going to have root 15 over 24x. However, what does it want us to show? 3 plus root 15x. 3 plus root 5 bracket x. That's slightly frustrating. Okay, so if I'm just going to put into my calculators, add root 3 over 8 equals. If I add them together into my calculator, I get 15 plus 3 root 3 over 24x. Okay. Now, they've changed. What they've done is they've multiplied everything through by root 3 over root 3. Okay. So we can times root 3 over root 3, which is still a whole one, and then we're going to have 3 plus root 5 over 8 root 3 x. Okay? That will still give you the 3 marks. Perfect. So, next up, what does it say? It says the surface area. So what does that mean? Surface area dA rate. What does that mean? T. So dA dt equals 0.025. So let's find the rate of change of the volume. So what do we want? dV dt when x equals 2. Give your answer to what? 2 significant figures. Okay, so now we need some t's involved, don't we? Okay. So if we want dV dt and we have dA dt, what do we want? We want dV multiplied by dt. Yeah? So what's the missing piece of information? dA. Oops. dA. Do we have dA dt? Yeah, what is it? 0.025. Do we have dV dA? Yeah, it gave it to us in the question. We just need to substitute in x equals 2. So we're going to have dV dt equals 3 plus root 5 lots of x, which we know is 2, all over 8 root 3, multiplied by 0.025. I'm going to put this into my calculator, and I'm going to get 0.01889 ... two significant figures, 0.019 centimetres cubed per second. Okay, so there is the whole of question 4. There's a lot going on there. Okay, so question number 5. Let's have a look. 10-mark question. Here it is. Pause it, take a quick read, and let's get started. So, the first thing we're going to do is, we know whenever we have parametric equations, we're going to have x equals the square root of 9 minus 4t, which we know can be written as x lots of 9 minus 4t to the power of a half. Okay? If we differentiate x with respect to t, we're going to have half 9 minus 4t to the power of negative a half multiplied by the differential of the bracket, which is negative 4. So, dx by dt is going to equal minus 2 lots of 9 minus 4t to the power of minus a half. So remember, when we're going to integrate y, I know we have t cubed over the square root of 9 plus 4t, but we're still actually integrating this with respect to x. So if we're integrating this with respect to x, we want it with respect to t. So I need to rearrange this to see what's happening. So what does dx equal? Dx equals minus 2, 9 minus 4t to the negative a half dt. So this is what I'm going to substitute in. I'm going to substitute this in instead of dx. So I'm going to have t cubed over. Actually, do you know? I'm gonna rewrite this. So t cubed 9 plus 4t to the negative a half. Everyone happy with that?
Yeah, they wanted
Times
they wanted in this form.
minus 2 9 minus 4t to the negative a half. We all happy with that? Okay, everyone's happy? dt. I'm just going to show you how we get to this form. Okay, this is the integral of this. So, essentially, we're going to have minus 2t cubed lots of 9 plus 4t to the negative a half lots of 9 minus 4t to the negative a half with respect to t. Now, forget about these negative to the halves for a moment. What do we notice about 9 plus 4t and 9 minus 4t? It's the factorised form of the difference of two squares. Yeah? There is no how. Yes? We're there? Perfect. Okay, so essentially this can be rewritten, this is to the minus a half of 9 plus 4t, 9 minus 4t. Now, I'm not sure, minus 2t cubed, I'm not sure if, you would have to show this to get the mark. We'll have a look at the mark scheme in a minute. So we're going to have the integral of minus 2t cubed over 9 plus 4t, 9 minus 4t, to the power of a half with respect to t, which we know is going to equal the integral of minus 2t cubed over 81 plus 16t squared to the power of a half with respect to t. Now, if we have a look, they've factored out the constant k, so this means we have minus 2 lots of t cubed over 81 minus 16t squared to the power of a half with respect to t. Okay, So k equals minus 2. Nice and simple. Now, just to give you something, normally we would change the limits here of when it gives us x equals. However, they've given us the limits of 2, so we don't need to change any limits, all right? So the limits are still between 9/4 and 0. Okay, we do not need to change limits. They've already done it for us in the question, which is nice. Then it says, using the substitution, u equals 81 minus 16t squared, find the area. Okay, so now an integration question. So u equals 81 minus 16t squared. Is that right? Yeah. Okay. So, what does du dt equal? Minus 13.2t. Okay, the second step, I need to rearrange this to figure out what t cubed is. I'm going to get u minus 81 divided by negative 16 equals t squared. Okay. So t equals the square root of this. What's 81 divided by 16? It's not a nice number, is it? It's 81 over 16. So, t equals the square root of this, right? So I'm going to have the integral of t cubed, which I'm going to get u minus 81 over minus 16, because that's t squared, multiplied by u minus 81 over minus 16 to the power of a half, divided by u. And then what's dt? dt is minus 1 over 32t du. That's what dt equals. So I'm going to write multiplied by minus 1 over 32t du. Okay, this is going to make our life so much easier because you know we've already got a t. That means that this square root that we've done, we don't need to, sorry, I forgot to put the half there. But you see how we've rearranged this to get the square root of this and it looks really awful. We don't need to write that anymore. We can just write t, which is fantastic news. Do you remember we did the trig question a few weeks ago and like we had this random cos, but then we had to divide by cos, so it was all good. Okay, so I can leave this as t because we know that this is t squared, t. Now what does this mean? It means these t's are going to cancel. It's a beautiful day. Okay, we don't have to integrate anything really awful. So, now, don't forget we still have the minus 2 out here, 9 over 4 and 0. So now what do we have? Let's see. So we're going to have u minus u over 16 plus 81 over 16 divided by u to the power of a half, 32u to the power of a half, which is a negative 30u to the power of a half. Okay. Okay, so let's do this slowly. Okay, so some of you are probably looking at this and no one in my classroom anyway is willing to attempt this. Have to go simply. Think of it this way. Minus u over 16 divided by minus 32u to the half. Okay? Which is the same as minus u over 16 times 1 over minus 32u. to the positive a half. So we're going to get positive u to the half divided by, well, 16 times 32. That seems outrageous.
Yeah, and that's why I saw
16 times
81 over 16 all over minus.
512.
Wait, hold on.
Why did you say?
Right, next one. 81 over 16 times 1 over minus 32u to the half.
You didn't finish.
So, this is going to give me 81 over 16 times 1 over minus 32 is minus 81 over 512 multiplied by u to the negative a half. Okay. Right, so now we're going to integrate between minus 2, 9 over 4, 0. Do you know what I just realised? Wait there, guys. We need to just change something on the previous question. Can you see we have between 0 and 9 over 4? That actually means that our limits here are between 0 and 9 over 4. Okay? The way that we change that is you get positive. If you want it between 9 over 4 and 0, it's going to be positive 2. You just multiply it by minus 1, okay? 81 minus 16t squared to the half with respect to t. Okay, make sure you do that. Okay, it's 2. No, because they already gave us the values of t. That's going to be positive 2, guys. Just watch out for that, sorry. Right, so now, this is with respect to du. Perfect. Okay, now this is t equals and this is t equals, isn't it? So what does u equal? 81 minus 16t squared. So we're going to have 81. Does anyone know what 9 over 4 squared is multiplied by negative 16 and added to 81? Okay, and 0. There we go. So I'm going to take out the 512. What's 2 divided by 512? 1 over 256. Okay, u to the half minus 81u to the negative a half with respect to u. Okay, now let's actually integrate this. Okay, increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Is that right? Yep. Right, now we're going to put this between 0 and 81. Now don't forget at the end we're going to multiply by 256. Right, let's give this a go. So 2 lots of 0 over 3 minus 162 lots of 0. Is everyone happy we're going to get 0?
I believe so.
Minus 2 lots of 81 to the power of 3 over 2 divided by 3 minus 162 lots of 81 to the power of a half. And they're going to multiply all of that by 1 over 256. So let's actually see what we get. Okay, so it's going to give me minus 972. Okay, I'm going to multiply that by minus 1 and 1 over 256, which is going to give me, minus 1 over 256 multiplied by that. It's going to give me 243 over 64 units squared. Perfect. Okay, so a little bit disappointing. It's a 10-mark question. It's taken us 14 minutes. However, we worked through it. We've got it correct. Now, the mark scheme has a completely different method. Okay? In the mark scheme, they rearrange this to find out what 1t equals, and then they cube it. However, I think this way, I know it took a bit longer with the division, it's definitely more efficient when we're cancelling out the entities. Okay? So, there we have it. Well done. Okay, question 6. So, for this one, we have 3 consecutive terms in a sequence of real numbers which are given by k, 1 plus 2k, and 3 plus 3k, where k is a constant. Use proof by contradiction to show that the sequence is not a geometric sequence. So, step 1, we're going to assume that k, 1 plus 2k, 3 plus 3k is a geometric sequence. Is a geometric. I'll tell you what, writing is hard, isn't it? Sequence. Okay, so we're going to assume that this is a geometric sequence. What do we know about geometric sequences? That they have a common ratio. So we know technically k multiplied by r should be 1 plus 2k. And then to get to the next term, we know we multiply r again. We should get 3 plus 3k. Okay? So therefore, we could say that 1 plus 2k divided by k is going to give me r, right? And also 3 plus 3k equals 1 plus 2k. This also equals r, right? So technically, we're going to say that 1 plus 2k over k equals 3 plus 3k over 1 plus 2k. So now we cross multiply. So 1 plus 2k, 1 plus 2k equals k lots of 3 plus 3k.
Alright, that's facts.
So this equals 4k squared plus 4k plus 1 equals 3k squared plus 3k. So then that means I have k squared plus k plus 1 equals 0. Okay, so then if I try and solve this, obviously, do you know 2 numbers that multiply to give you 1 and add to give you 1? No. If we use the quadratic formula, we're going to have no solutions. We're going to have imaginary numbers, right? Because b squared minus 4ac is going to be less than 0, what do we have? There's no solutions. Therefore, this contradicts. I think when we do the assumption, we have to assume that k blah, blah, blah is a geometric sequence and has a common ratio r. Okay? Okay, so it's okay for us to go back and change what we're assuming because actually what we've proved is that there is no common ratio r. So b squared minus 4ac has no solutions. Therefore, no common ratio r, which contradicts a geometric series, geometric series. And then I think we'll have to put something in lines of, therefore, this sequence is not geometric. Therefore, proved. Okay. Right, I think as well, something that we need to highlight, it does say a sequence of real numbers has no, I think we should put here, no real solutions. Okay, so just make sure we're using the wording right. Yeah, just make sure you use that wording and then you should get 5 marks. Okay, maybe it might be good to write, you could even do, just to be sure, you could even do 1 squared minus 4 lots of 1 lots of 1. is the square root of -3, which is not real. You know, like, just fluff it up a bit if you think you might need to. Perfect. Okay, question 7. So, this looks interesting. We have a doorknob.
Hold up.
And it's formed by rotating the curve shown in figure 4 through 360 degrees about the x-axis where the units are centimetres. Okay, what I love about these questions, if we're rotating something through 360 degrees, what's happening? Yeah, volume. Absolutely. So, whenever we think of volume, I want us to do this. The integral of pi lots of y squared dx. We know that's what's going to happen here. Okay, so here is the equation of the curve. It's wonderful. Now, it says, show that the volume of the doorknob is given by this equation. So what do we have to do? We have to integrate between pi, and we're going to square a quarter, 4 minus x, lots of e to the x, all squared with respect to x. Okay, so what do we get? What's a quarter squared? 1 over 16. 4 minus x squared, e to the power of 2x with respect to x. Now, if I have a look at what they've done, have they got a fraction here? So on the outside, what are we going to have? Pi over 16 integral of x squared minus 8x plus 16, when I expand the bracket, e to the 2x with respect to x. Okay, so our k equals pi over 16. Nice and easy, 3 marks. So now it says, hence find the exact volume of the doorknob. This is lovely. Okay, so here we have it. Right then, we need to integrate between 4 and 0. Oh my God, I'm already in love with this question. Right, let's integrate between 4 and 0 of pi over 16. Now, what's the first thing you notice? What is this?
7 over.
It's a product.
It says 7 over.
Okay, so this is a product. So what we're going to do, step 1, let's multiply everything out. Make our lives easier. We don't have to, okay, actually, I'll give you the option. You want to multiply this all out and do each one individually, or you want to do the whole thing as 2 products?
Can't you do by parts?
2 products. Okay, so we know that when we have products, what are we doing? Integration by parts. Magic number 7. Okay, whenever we have an e, it's likely that we're going to put it here. What's left? X squared minus 8x plus 16. Okay, if we go down, what do we do? Differentiate. So we're going to get 2x minus 8, integrate, e to the 2x, divide by the differential of the bracket. Okay, so step 1, we're going to have this, which is e to the 2x over 2 multiplied by x squared minus 8x plus 16 minus the integral of, bracket, 2x minus 8 lots of e to the 2x over 2 with respect to x. Okay, what do we notice again? Do we have another product? Double integration by parts. We're going to have 2x minus 8 and e to the 2x over 2. When I go down, I differentiate. We're going to get 2x. When I go up, we're going to integrate. Oops. Which is going to give me e to the 2x. Oh. Wait there, guys. Sorry. There we go. It's just a 2. Right, so is this e to the 2x divided by 4? Perfect. So remember magic number 7. So, watch out for this. E to the 2x over 2 lots of x squared minus 8x plus 16 minus, okay, 2x minus 8 e to the 2x over 4 minus the integral of 2 times, so this is just going to give me a half, 2x over 4. Remember, we're going to times these together. With respect to x. Right, we're nearly there. So now I'm going to have e to the 2x. This is over 2. Right. E to the 2x over 2 lots of x squared minus 8x plus 16 minus 2, actually I'm going to rewrite this, minus e to the 2x over 4 lots of 2x minus 8 minus e to the 2x over 4 plus c. However, do we need to write plus c? No, because we're going to integrate this between 4 and 0 and multiply it by pi. Not integrate it, sorry. Substitute. Yeah, obviously by pi over 16. Okay, just make sure, don't get carried away like I do. Right, are we ready? So, if I substitute 4, if I substitute 0. Oh, here we go. Let's leave pi over 16 out for a while. Right. E to the 8 over 2. Lots of 16 minus 32 plus 16. Minus e to the 8 over 4. Lots of 8 minus 8. Oh, this is looking good so far. Minus e to the 8 over 4. Okay, make sure someone's checking what's happening here. Oops. Minus. I would not suggest putting this into the calculator. It wants an exact form. E to the 0 over 2. Lots of 0 squared minus 0 plus 16. Minus e to the 0 over 4. 0 minus 8. Minus e to the 0 over 4. Okay. So, 16 minus 32 plus 16. Is everyone happy that this is definitely going to give me 0? This is going to give me 0. Yeah, what's 8 plus 8? 0. Okay. So then, I'm going to have pi over 16, lots of minus e to the power of 8 over 4. Okay, now let's sort out this side. I'm going to get 16. What's e to the 0? 1. I'm going to get 16 divided by 2 is 8. So I get 8 here. Minus. Minus a quarter times minus 8 is minus 2. Minus 2. Minus a quarter. What's 8 minus 2 minus a quarter? 6 minus a quarter. 5 3/4. Minus 5 3/4. Okay, what does it even want? Let's go back to this. Give your answer where p pi eq plus r, where p, q and r are simplified rational numbers to be found. Okay, can you see? I'm going to do something really cool. You might not think it's cool, but I think it's really cool. Yes. Let's move that. I just learned how to do this the other day.
Not in our capabilities.
I didn't know that we could do this, did you? There we go. Okay, can you see how it wants e on its own? So, what do I also need to take out? Probably negative a quarter, right? To get the positive e. So if I take out negative a quarter, I'm going to have negative pi over 16 times 4, which is 64. Lots of positive e to the 8 plus, now we need to do 5 1/4. It's 23 over 4, so it's just going to be plus 23. Okay, there we have it. Nice and simple. So, there's been a mistake. If you spotted it, you are amazing. First of all, what's a minus times a minus? It's a plus. This is so easy to do. Okay, again, I'm going to blame people in my classroom for not spotting this. Okay, then, also, what is minus a quarter times minus 8? This should then be a plus. Plus. This is going to give me, oops, oh my. Yeah, this is going to give me positive. Okay, so this is going to be minus plus 41 over 4. And then we're going to get minus 41. Okay, if you spotted that mistake as I did it, well done. If you didn't spot it at all and you were going along with me, that's great. However, it needs to be on the ball and sharp. This mistake's really easy to do, and you can see, I think it would have cost us a few marks. So well done. Question 8. I know what you're thinking. We haven't had it yet, have we? Vectors. Here it is. Now, this is a really lovely vectors question. Okay. So, with respect to a fixed origin, O, the points A and B have position vectors, blah, 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 respectively. The line L1 passes through the points A and B. So, for any line, okay, we know that R equals a point plus lambda direction vector. Okay? So, how are we going to find this point? Okay, so we can pick any point, 6, 6, 2, and then the direction vector. How do I get from 6 to 6? 0. How do I get from 0 to 6? Minus 6. How do I get from 7 to 2? 5. So we're going to have 0, minus 6, 5. Give your answer in the form R equals P plus lambda Q. Done. Okay, so you could have also had your direction vector as 0, 6, negative 5. It doesn't matter. It means. Okay, also if you had this one, that's completely fine. It's still equivalent. So, now it says part B. We have this equation and it says where mu is a scalar parameter, show that they do not meet. So this is really easy. We also have our equation R for L1, right? So it doesn't matter which one you use. Okay, if you use a different one, you should still get the same answer. So if we have to show that they do not intersect, this is fantastic. We're going to equate them. So we're going to have 3 plus mu equals 6. Then we're going to have 1 plus 5 mu equals 6 minus 6 lambda. And then 4 plus 9 mu equals 2 plus 5 lambda. Okay, for those of you who still don't know where I've got this from, 3 plus mu equals 6 plus 0 lambda. Okay, 1 plus 5 mu is 6 minus 6 lambda. If I'm staring at anyone in particular, I'm just staring. Okay. Okay, next up. So now we got mu equals 3 from the first equation, minus 3 from both sides. So now that means that on the second equation, 1 plus, what's 5 lots of 3, equals 6 minus 6 lambda. Okay, so that means 1 plus 15 equals 6 minus 6 lambda. So I'm going to get 16 minus 6 equals minus 6 lambda. 10 equals negative 6 lambda. So minus 10 over 6 equals lambda. Some of you may have written that as minus 5 over 3. This is also correct. So now let's see if this is true. So 4 plus 9 lots of mu, which is 3, should equal 2 plus 5 lots of lambda, which is minus 5 over 3. I can already tell you they're not going to equal. However, let's keep going. What's 4 plus 9 times 3? It's 4 plus 27. What's 4 plus 27? 31, absolutely. Okay? What is 2 minus 25 over 3? Minus 21 over 3. Okay? These do not, I repeat, do not equal each other. Have you ever seen 31 look like negative 21 over 3? No, neither have I. Okay? So therefore, L1 and L2 do not meet. Sorry, everyone. It's minus 19 over 3. However, they still don't equal each other, so they don't meet. Sorry. Okay, then. Part C. The point C is on L2, where mu equals negative 1. Find the acute angle between AC and L2. Maybe I missed it, but I don't know where A is. With respect to the points A and B. Okay, so A is 662. The point C is on L2 where mu equals minus 1. Okay, so let's work out what C is. C is going to be 3 minus 1, 1 plus 5 lots of minus 1, and 4 plus 9 lots of minus 1. Okay, I've just substituted this into the equation where mu is minus 1. That's how we're going to figure out the point. So I'm going to have 2, 1 minus 5, minus 4, 4 minus 9, minus 5. Someone check that, please. Yeah. Perfect. Right, so find the acute angle between AC, so the line AC, and L2. Okay. So, how do we find the angle? Dot product. What is the dot product rule? Cos of theta equals D1 times D2 the magnitude of the direction vectors, absolutely. So the direction vector of D1 is going to be the direction vector A to C, which we know is C minus A. So 2 to 4. How do I go from 2 to 4? Sorry, 2 to 6 plus 4. How do I go from minus 4 to 6? 10. How do I go from minus 5 to 2? 7. Okay, so we're going to have 4 10 7 times, well, is it times or the dot product? What's the direction vector of L2? 159. Right. Oh, golly. So, sorry, I've written this wrong. Needs to be, I feel like, I think my iPad pen's died. Okay, so we've done, why have we done C to A? Sorry, I've written that wrong. That is because if we were to sketch this out, our line L1 is going to look something like this. Our point C is here, and our point A is going to be here. And if we're trying to find the angle, we need both direction vectors to be coming out. Okay, so now we're going to have then the modulus of each one. Oh, it's not even modulus. Magnitude. Okay, so what's 6 squared plus 6 squared plus 2 squared?
4 10 7.
So 4 squared plus 10 squared plus 7 squared. 1 squared plus 5 squared plus 9 squared. Rooted. Okay, so what do we get on my numerator? 117. 4 times 1 plus 10 times 5 plus 7 times 9?
Yep, and add them up,
Yeah.
yeah?
4 times, and then we're going to add the sum of that up. 7 times 9, 63. Perfect. Right, then what's the square root of 4 squared plus 10 squared plus 7 squared? 149 plus 16, what do we get? Root 165. And then root 107. Great. So, 117 divided by root 165 times root 107 equals 0.88. So cos theta equals 0.8805, etc. Should I be in degrees or radians? Degrees. Yeah, let's make sure we read the question. Shift cos answer 28.29 equals 28.29 dot dot dot. It wants one decimal place, 28.3 degrees. Okay, perfect. What would happen if it didn't want the acute angle, it wanted the... It wouldn't be obtuse. Reflex. It would want reflex, yeah. It would want reflex for cos. Okay, so make sure we know that, yeah? If it wanted reflex. Because think about the cast diagram. Cast diagram. Just be careful what it says here. What does acute mean? Yeah, so make sure you know what's happening. Okay? If it wanted something else, just read that because you know that they could do something funny. Okay, question 9. Find the derivative with respect to y of this. So essentially, if we want respect to y, what should we be doing? Okay.
So if you differentiate y, it would just be 1, right? Because it's with respect to y.
Yes. So, how are we going to differentiate this? Chain rule. Negative 2. So we know that this is the same as 1 plus 2 ln of y to the power of negative 2. How do we now differentiate this? Negative 2 bracket 1 plus 2 ln y to the power of negative 3. And we need to multiply by the differential of the bracket. What's the differential of 1? 0. What's the differential of 2 ln y? 2 over y. So then, we're going to have minus, this is going to equal minus 4 over y lots of 1 plus 2 ln y all cubed. This is how you could write it as. Okay, 2 marks, nice and easy. B, hence find a general solution to the differential equation. So we've already done like part of it. So part B. Step 1, when I have a dy dx involved, what on earth do I need to do? Y is on one side, x is on another, etc., etc. So, what are we going to get? 1 over y lots of 1 plus 2 ln y cubed with respect to y equals 1 over 3 cosec lots of 2x with respect to x. All I've done there is cross multiply. Okay? I haven't done every single step. We should be okay by now. Now what do I need to do? Integrate both sides. Now, first of all, we had to differentiate this. And this is what we got. So this is actually integration by assumption. So if I differentiate this and I get this, what's the difference? Yeah, so this is when so if you think about it, if I was to integrate this, I'm going to get this.
Yeah.
So what do I need to do? If I've got minus 4 lots of it, divide by negative 4. Okay, so what's this answer going to be? minus 1 over 4 lots, yeah?
Yes.
This is going to be minus 1 over 4 lots of 1 plus 2 ln y all squared. And the other way to see it is imagine if this was negative a quarter, and we would then multiply everything by negative a quarter, which would give us 1 here. Yeah? Okay. Now, next up, on the other side, oh, don't forget there's a plus c somewhere lurking around. Maybe we'll put the plus c on the other side, but we just have to remember that. What is cosec? What is 1 over cosec? 1 over sine. So 1 over cosec is actually just sine. Now, listen carefully. This is still the integral of a third sine of 2x. If anyone brought that 3 up with it, you are a fool. Okay. I can't say that. Right, 1 over 4 lots of 1 plus 2 ln of y all squared equals, what do we have? Sine, cos, minus cos. Integrate, which way do I go? Anti-clockwise, okay? So, if we integrate, I'm going to get minus a third cos 2x, and what else do I need to do? Divide by the differential of the bracket. I can't believe people are shouting times 2 at me. What's a third divided by 2? A sixth. Plus c. Okay, I'm not sure what's going to happen with c, but it will probably be a ln or something. Who knows? What does it want us to do? Find a general solution to the equation. Okay then, so this is lovely.
Isn't a general solution just an integral?
We're going to have to sort out this c. Okay, so here's a heads up. If it says general solution, it means just integrate both sides. Make sure you've got the plus c. If you don't get plus c, you're not getting the full 4 marks, okay? And once we've done that, this is going to give you 4 marks. Okay, part C then says, show that the particular solution of this differential equation for which y equals 1, x equals pi over 6 is given by this. Okay, so first of all, I'm going to substitute this all in and find what? C. Do I need to find C? Yeah. Okay then, so 1 and pi over 6. So 1 over minus 4 lots of 1 plus 2 ln of 1 squared equals minus 1 over 6 cos 2 lots of pi, was it over 3? No. Over 6, thank you. Plus c. Okay, so what is ln of 1? 0. So literally, I'm going to have minus 1 over 4 plus 1 over 6 cos pi over 3. What does that give me? Make sure your calculator's in what? Radians. Okay, so minus a quarter plus a sixth cos shift pi over 3. Minus a sixth. It's fantastic news. Okay? So that means we have minus 1 over 4 lots of 1 plus 2 ln of y all squared equals minus 1 over 6 cos of 2x minus a sixth. Oh, they're being very naughty. Do you see it? Minus 1 over 6 cos of 2x minus 1.
Cos 2x minus.
What did you just say?
Yeah.
Oh, that's sine.
So this is minus. 1 over 4, 1 plus 1. Y squared. Okay, are we happy that from here the negatives will cancel?
Yeah.
Yes. I can't believe that.
Okay, I'm now going to cross multiply because I want to try and get y equals, right? So this is what I'm going to do. I'm going to multiply both sides by 6. Happy?
Sounds right.
Multiply both sides by 1 plus 2 ln y all squared. Okay? Divide both sides by cos of 2x plus 1. Happy? And this just becomes over 1. So this is where I'm at. Is everyone here with me? And what does it want?
So 1 squared stays the same if you take that outside the bracket.
Okay, I'm going to bring this here. Because this is what we want, right? Oh, there we go. This is going to help us. First of all, we know we have to get y on our own, yeah? So, what do I now have to do? Yeah, square root. This looks awful. Okay, before we square root, let's sort some stuff out. Are we happy that we're going to have 3 over 2 sec of 2x? Pardon? Well, 1 over cos is sec.
No, it's cos 2x plus 1.
Plus 3 over 2. Is that better?
That's fair.
I hadn't finished my sentence. Okay. I don't want to square root this. Equals. Are we actually going to square root this? Oh. They don't have a root 3 in theirs. Let's square root it. 1 plus 2 ln of y. Yeah. I don't like it. I really don't like it. Okay, I really don't like it. I don't like these square roots. So now, I'm scribbling it out. What do I know about cos of 2x?
1 minus 2 sine squared.
It's 1 minus 2 sine squared x.
It's an identity.
And then plus 1. Is there any other identities? I don't think I want sine. 2 cos squared x minus 1 would be better. Okay, it's okay. So this is 2 cos squared x minus 1. Okay, this is a better identity. So the reason why I'm using the cos here is because of the sec. Yeah? And I have an x here, I have an x here. Minus 1, and then it's plus 1. Oh, this is going to be nicer. So listen. So straight away, you know earlier when I said, oh, they've been a little bit naughty, it's because I saw that straight away and I knew they wanted an identity. So what you have to think to yourself is, you know when I said, oh, what do we do now? And everyone's like, square root. That looked horrible, didn't it? Always go back and think, does this make sense? So now I'm going to have 6 over 8. What's 6 over 8? 3 over 4. Cos squared sec squared x. Okay, this is it. Equals 1 plus 2 ln of y all squared. Okay, so now we can square root both sides. So So I get root 3 over 2 sec of x equals 1 plus 2 ln
Don't square root the second.
y. Yeah, sec squared square root of just sec. Okay, so I'm going to get root 3 over 2 sec x minus 1. Everything now, I'll just keep going. Ln y. What do I do now? Okay, so root 3 over 4 sec x minus what? Minus a half equals y. Ln. How do I get rid of the ln? E to the root 3 over 4 sec x minus a half equals y. Is that what they want? Oh, I tell you what, that was beautiful. Okay. Therefore, proved. Okay, well done, everyone. This was a great paper. Okay, good luck for your exams.